Hey everyone, have you ever wondered how Netflix knows what shows you'll binge next? Or how your email filters out spam automatically? The answer is machine learning algorithms. Today we are breaking down the basics of machine learning algorithms in the simplest way possible. Whether you are completely new to this or just curious, by the end of this video, you'll understand the fundamental types of algorithms and the math that powers them. So let's dive in. So the first things first, what actually is a machine learning algorithm? Think of it like a recipe. Just like a recipe takes ingredients and follows steps to make a dish, a machine learning algorithm takes data as ingredients and follows mathematical steps to make a prediction or a decision. The beautiful thing here is that the algorithm learns and improves from experience. The more data it sees, the better it gets. Just like how you would get better at cooking the more you practice a recipe. Now, machine learning algorithm falls into three main categories. The understanding these is a key to understanding everything else too. Largely, there are three types of learnings, and each of these algorithms fit in either of these categories. The three categories are supervised learning, unsupervised learning, and reinforcement learning. So let's dive deep in them individually. Supervised learning. So this is like learning with a teacher. You give the algorithm examples with correct answers, and it learns to predict answers for new examples. For example, you show it thousands of pictures of cats and dogs, each labeled as cat or a dog. After training, it can look at new pictures and tell you which one it is. Some of the common algorithms here include linear regression for predicting numbers like prices of house, logistic regression, which are yes or no decisions. For example, deciding if an email is a spam or not. Decision tree, which asks a series of yes or no questions to reach to a conclusion. And then neural networks. This is inspired by human brain. This can learn incredibly complex patterns. Next we have unsupervised learning. So this is like exploring without a teacher. The algorithm finds patterns in data without being told what to look for. Imagine you have customer data but no labels. The algorithm might discover that your customers naturally fall into groups, for it like budget shoppers or premium buyers or occasional visitors. The key algorithms here include key k-means clustering, which groups similar data points together. Then we have principal component analysis or PCA that finds the most important features in your data. Now the third and the final category of learning is reinforcement learning. This learning is by trial and error. Like training a dog with treats, the algorithm tries actions and gets rewards for good ones and penalties for bad ones. And learns the best strategies over time. The goal here is that you penalize the algorithm for any bad decisions and reward them for any good decisions, and the goal is to maximize their points or rewards. This is how an AlphaGo learned to beat world champion at Go, and how self-driving cars learn to navigate roads. Now, let's talk about the math, but don't worry, I'll keep it simple. Okay, let's start with linear equations. The simplest form is y is equals to mx plus b or mx plus c, however you have learned it in your childhood. This is just a line where m is the slope, b is where it crosses the y-axis. Linear regression uses this to find the line that best fits your data points. If you're predicting house prices based on size, you're essentially finding the best line through all your data points. Next, we have polynomial equations. These are curves where y is equals to ax square plus bx plus c. This is where your data doesn't fit in a straight line, you need curves. This helps capture more complex relationships like how crop yield might increase with fertilizer up to a point and then decrease if you use it too much. Next, we have probability or statistics. Algorithms like naive Bayes uses probability. If 90% of spam emails contain the word free, then an email and then if an email has free in it, there is a high probability it's a spam. The algorithm calculates that probability mathematically. Then we have distance calculation. For clustering algorithms, we measure how close data points are. The most common is the Euclidean distance, basically a Pythagoras theorem, where we calculate distance using this formula. Points that are closer together are then grouped together. Next, and the final one, we have gradient descent. This is an optimization technique most algorithms use for learning. Imagine you are blindfolded on a hill and want to reach to the bottom. You would take a small step in the direction and that goes most downward. That's gradient descent. The algorithm takes small steps to minimize errors and improve prediction. The equation looks like something like this on the screen. So here's how it all works in practice. There are three steps for building any machine learning algorithm for a production environment. The first step is that you choose your algorithm. If you need to predict a number, you would choose linear or polynomial regression. If you need to classify things, you would use logistic regressions or decision trees. If you need to find patterns, you would find clustering algorithms. If you need complex pattern recognition, or if you want to land a rover on Mars, you would use neural networks. You would use these models and feed the algorithms your data. It makes predictions, usually terrible at first, then it calculates how wrong it is using a loss function, and then it uses gradient descent to adjust its parameters. And this is repeated for thousands of times until the predictions are accurate, or if I had to say it statistically, you had more confidence in the algorithm. Usually, you divide your dataset into two parts. One is the training dataset, and the second is untraining dataset. When you use the training dataset, you expose both inputs and outputs to the training dataset and train the model, and then validate with the remaining untrained dataset to see if the models is accurately behaving or not. Finally, you will test and deploy it. Once trained, you test it on the new data with which it hasn't seen. It could be your untrained dataset or it could be data from production environment. Now remember, a machine learning algorithm or a machine learning product never a, is never a single line production. It's always a closed circle production. What I mean is that after testing and deploying any AI model or any machine learning algorithm, you would constantly go back to the training process, exposing your model with the newer data so that it could adjust with newer trends and give answers accurately with change in time. Alright, so there you have it all. We have covered the three main types of machine learning: supervised, unsupervised, and reinforcement learning, along with the key algorithms and mathematical concepts that power them. The amazing thing is that these same fundamental concepts power everything from recommendation systems to medical diagnosis to self driving cars. You now have the foundation to dive deeper into any of these topics. If you find this helpful, give this video a thumbs up and subscribe for more beginner-friendly tech content. Drop a comment below telling me which algorithm you want to learn more about. Thanks for watching, and I'll see you in the next video.